Hello students! So far we have learnt about carbon compounds that have hydrogen and carbon together called hydrocarbon compounds. But are all carbon compounds hydrocarbons only, or do they have any other atoms in addition to hydrogen and carbon? If all compounds had only hydrogen and carbon, then the properties of all compounds would be same, isn't it? Yes. But this is not true. We know that there are wide varieties of carbon compounds with wide varieties of properties. And these different properties are due to the different elements present in them. This leads us to a different concept called functional groups. So, what is this functional group? Simply put, a group is a collection of atoms, and functional means it serves an important purpose. This explains to us that functional groups are sets of atoms that play an important role in determining the functionality of a compound. Or they are groups of atoms that impart definite properties to the compound with which they get attached. An important thing to remember is that these functional groups impart unique properties to compounds, irrespective of the chain length or side chains attached to them. Let's understand this in detail. As we have seen earlier, carbon can form bonds with many other elements, such as halogens, oxygen, sulfur, nitrogen, etc. These elements replace one or more hydrogen molecules in the hydrocarbon chain. But while doing so, it is always ensured that the four valencies of each carbon is always satisfied. In such compounds, the elemental atom that displaces the hydrogen atom is known as heteroatom. These heteroatoms and groups of atoms, that is functional groups that contain them, give a special properties to that compound. Say we have a compound made up of chain of 5 carbon atoms. The carbon chain may be straight or branched. Now this hydrogen is replaced by a functional group, say halogen group or alcohol group. This forms a new carbon compound with new properties. And why is this? It is because of this halogen atom or alcohol group that joins with it. If you observe, this is a saturated hydrocarbon chain. This is also true for unsaturated hydrocarbon chains with double or triple bonds. Now in any of these cases, the properties of compound depends on two things. First, whether it is saturated or unsaturated. That is, whether it has a single, double or triple covalent bond. But this is very minor. And secondly, the presence of functional group. It is this group that gives a major part of peculiar properties to the compound. Thus, a functional group can be defined as a group of heteroatoms attached to a hydrocarbon chain that gives it a peculiar properties and functionality. Now let's get information about different functional groups. The few functional groups that you will study are aldehydes, ketones, ethers, amines, esters, and so on. Observe their structure carefully. What do you notice common in them? Yes, we find that any one atom in the whole functional group is ready for bond formation with any other atom. And we represent this by drawing dash in front of that atom. Wait a second. What does this dash in front of these functional groups indicate? It indicates that this group is now available for bond formation. Precisely, it shows the free valency of that given atom in this group and thus its ability to form a covalent bond. Clearly, all of them have valency 1, meaning they can bond to a carbon atom of a hydrocarbon group or alkyl group by a single covalent bond. But wait, what did I just say? Did I say alkyl group? Yes, I said that any functional group is capable of bonding with the carbon of the alkyl group. So what do we mean by alkyl group? Alkyl group in chemistry is a group of carbon and hydrogen atoms derived from respective alkane compounds by removing one hydrogen atom. We have seen what alkanes are, isn't it? Yes, they are hydrocarbon compounds with a single covalent bond. If we remove one hydrogen from these compounds, we find that they are now capable of making bonds with other compounds. Let us take the example of methane to understand this. Looking at this molecule of methane, we find that here all four valencies of carbon are complete. As a result, it is unable to form any other bonds. But what if I remove this hydrogen from here? Obviously, its one valency now becomes free, and this carbon can now form new bonds. In our case, it can bond with the functional group from this point, like this. This structure that you see without hydrogen is called the alkyl group. It is represented by capital letter R. The name of the alkyl group is derived from the name of its alkane by replacing the "-ane" suffix with "-ile". Since in our case, this structure is derived from the corresponding alkane methane, its name will be methyl. If we have ethane here, and if we remove its one hydrogen, the corresponding alkyl group will be ethyl. And if it is propane, it will be propyl, and so on. As you can observe that all these functional groups have any alkyl group R or R dash attached in front of the dash. Thus, all functional groups have one atom which can bond with the carbon of alkyl groups like methyl, ethyl, propyl, butyl, etc. We will see all of these functional groups, their structure and function in detail in our coming videos.